This
if anybody has
conference
any
will
issues
now
hearing
be
us
recorded.
online, go ahead and let us know. For the sake of the shift workers and folks that can't make today's meeting, or you can't make the pretty much the same content to be repeated on August 27th, we're going to record this particular presentation and discussion today, so folks can hear it back later, and we'll provide that via email here in a couple weeks. We'll get started here in just a moment. It's already recorded.
Sit too close to them, strength, but if it's too far back.
I have to click on it because you unmuted.
Excuse me.
Everybody, I'm Andy Latto. I'm actually a former NWS employee, now working for GeoXO as the user engagement lead. Mentioned for those who haven't joined yet, a recording will be available after this in case anybody misses this, and the similar event that's going to happen again on the 27th of August. If you can't make today, those that didn't make today, they can attend that one or listen to this recording. So this is part of a series we developed. It's called NOAA's Satellite Application Symposium series. The themes, of course, for today's weather, specifically for NWS staff. There's specific needs that the NWS staff has, and we have our user scientists here today with us to have some discussions with the folks regarding some of the new and upcoming capabilities for the satellites that you'll use every day. From a GeoXO's perspective, so we're going to be the next constellation, next generation from what you have now for GOES. And this is going to be several years from now, but there's a lot of work to be done between now and then to get ready for that program. So we're ramping up our engagement activities with users like yourself, again, to establish some of the data needs and other aspects of things coming up in the future. So I mentioned this symposiums. What we're going to do is we have these themes: water, which is kind of ocean color. There's weather. There is air, which is more like air quality, pollution, human health factors, and fire. And we're going to have these meetings. We're going to start slowing down the cadence. Like every couple of months, we'll change themes, but we repeat the themes again. So now we have weather this month. Maybe in about 6 months or so, do it again. And kind of build on what we've learned from the folks today and follow up after these meetings with anything else we need to learn in the process of creating these meetings. And as we get closer to launch, we'll get more in depth, maybe do like data workshops and things like that. And for GeoXO, if you just Google GeoXO events, you can find information about these thematic meetings or anything else we are building on our own and for the GeoXO side. Also, you've probably already seen the emails. There's a VLab webpage that's also being updated. It's tailored more for the Weather Service side. So if there's any Weather Service specific events, you can get it on there. I'm going to pass it on for a moment virtually to Kat Hawley. She is the LEO user engagement lead, and she wanted to speak for a couple moments about some of their plans in the near future. Kat, are you on?
Yes, can you hear me?
Yep.
Okay, thank you so much. Sorry, I'm having difficulties on turning on my camera. Thank you so much for having me on this call and being able to speak very briefly about user engagement on the LEO side, the low Earth orbit. I am also a semi-recent meteorologist from the National Weather Service, and today I'm here to talk briefly about what we have in plan for the LEO user engagement. As a program, we are just starting to figuring out what our next generation of LEO satellites may look like. And in that process, we are trying to speak with meteorologists across the National Weather Service to understand how information is critical to their jobs. And we are currently doing a socioeconomic study. And so I would like to kind of just put a birdie in people's ears to see if anyone is interested to helping us document. This information is very critical because we will be able to convey up to the Hill and to ONB and to NOAA leadership on why certain instruments are very critical for your operations. For example, we are right now working on a socioeconomic study on hurricane track and intensity. We are trying to uncover how important the microwave sounder is into forecasting a track and intensity forecast and how it plays a direct role on societal outcomes. For example, we're investigating how information is integrated from the Hurricane Center to a local forecast office, to regional operation centers, and down to their direct users such as emergency managers, Red Cross, Department of Transportation, and funneling through to local law enforcement such as fire departments and police departments. So I'm curious if other folks would like to participate that are on this call. We'd love to interview you to understand how microwave sensors, infrared sensors, imagery, and so forth integrate into your decision processes. And so we will have a full outlook and updates on other topics that we're going to be looking into by AMS. So please stay tuned, and we'll have updates on our website and social media as well. And I'm going to pass it back to Andy, and thank you so much for allowing me to take a few minutes to talk about this.
All right, thanks so much, Kat. Anybody have any questions so far before we proceed to the GeoXO program update here or online? Okay, next up we have Andy Heidinger. He's joining us virtually. He's senior scientist at the GeoXO program to talk about a brief program update to what's been going on with this new program.
Great, thank you, Andy. Am I driving, or are you driving?
I'll drive.
Okay, great. Yeah, I'm taking slides from Pam Sullivan, who is our program director. She couldn't give this intro, so I'm filling in for her. But it's an honor. You know, we have both Leo and Geo really look to the Weather Service as our most valued partner. So next, GOES-R development, ends and GeoXO begins. We just launched our GOES-U, the last of the GOES-R series. And we have a mandate that we have to have a spare imager in space. And our flyout charts tell us that need begins in 2032. So that's our program, GeoXO, the next series. We've got to get on orbit in 2032. And we've kicked off the program. You've probably heard of it already and maybe seen some of these slides, but that's our driving force, is to get there by 2032. Next slide. So our constellation, GeoXO is a big expanse above GOES-R, which of course, as you know, is a big expanse above the GOES I through M series. So we are breaking the paradigm of east and west by adding a central satellite. So on east and west, as is today, you'll have an advanced imager and a lightning mapper, but also an ocean color sensor. And in the central, you'll have this kind of our sounder payload, where you'll have the infrared sounder and an atmospheric composition instrument that's not too different from the NASA Tempo that's already in space. And if we're lucky, we will get a partner payload, yet undetermined, as an additional instrument on that central platform. Currently, its sub-LON is 105, so it's shifted a little bit in this image, but it'll be over like Fort Collins area. And our downloads will, we'll have a lot more data, so things will change, but our basic stations will remain the same. Next slide, please. So here's a kind of a cartoon of all these new instruments, and it's color-coded by the NOAA mission areas that we think these will contribute to. Of course, this is only our guess, and as these things get used, I think they'll filter their way to all the mission areas. But you'll see, of course, the GXI. This is our imager. It's incrementally better than our ABI, and I'll show those increments. And our lightning mapper is also the LMX is a follow-on to the GLM. The sounder, I'll also discuss. This is, again, it's hyperspectral, so think of CRIS in GEO, and it'll provide all of those capabilities that we think when we hope the Weather Service needs. The two instruments on the right are those probably not initially weather contributors too much, but I'm sure they will be used. ACX, again, this is an air quality, measures pollution, aerosol heights in a way that's much superior than we've done before. Then the ocean color sensor, again, it's hyperspectral, very fine resolution of 300 meters, and it will scan all our coastal regions, including the Great Lakes and the Gulf of Mexico. So again, I'm sure that the creative people on this call and the Weather Service will find utility for those instruments once they're up. So next one, please. So talk about the imager. Again, this is an incremental improvement above the ABI. There's two main improvements. There's 2 new channels. So we worked with the Weather Service, and they selected from a menu of possibilities 2 new channels, one at 0.91 microns, one at 515. Both of these are water vapor channels, low-level water vapor, and we know that's a critical need. So that'll be, GXI will be, the most water vapor capable imager ever. In addition, we've got some critical shift to lower spatial resolutions. So you'll see we have a couple IR channels, 3 IR channels or 4 shifting to 1 kilometer, which we never had on ABI, including the fire channel. So that'll be quite powerful for fire monitoring. Several of the visible bands that were 2 are now 1, and most notably, our visible channel went from 500 meters to 250, which is, I think, incredible. And you can see here, for those that know where Nantucket Island is, off the coast of Massachusetts, ABI is on the left, and what we will see from GXI is on the right. So again, this general march to more channels, finer resolutions continues with GXI. Next, lightning mapper. And I should say, all of our sensors have been selected, their vendor has been selected, except the lightning mapper. So when I say I can only show what the requirements were for the lightning mapper. Once the vendor is selected, those will change to what they proposed. But basically, again, this is an incremental improvement above the GLM. It's an optical lightning measurement. Again, I put these required values, again, that are not too different than the GLM, but we hope, again, to expand its coverage near the limb and continue the great observations that we have from GLM. As this image here is kind of a cool one that you can only do with optical lightning is detect this, what we think is the world's longest lightning flash detected by GLM. And again, this is, as you well know, first ever for GOES-R, and it's a measurement that we're still learning how to optimize and learning cool things. And that will continue with GeoXO. Next. Our sounder, GXS. So again, this is a hyperspectral sounder. Same spectral resolution as CRIS, not the same coverage spectrally, but it's close. So you can think of this as providing CRIS-like ability to retrieve water vapor and temperature profiles from GEO. There's some details here on how it scans, but I think the important thing, it scans quite fast. So if we choose to, we'll be able to take a full disk every 30 minutes, which is quite a bit faster than the other hyperspectral GEO sounders planned for orbit. And so we are very, very interested to work with the Weather Service as how to use that high temporal refresh for all the, the storm tracking, severe weather, and applications that you'll get, including, of course, the rank and file data assimilation things that come from IR hyperspectral soundings that the LEO program has shown for years. So again, we're very excited. This sensor will be delayed a bit, the central platform. We're thinking 2035, so we have plenty of time. Europe is going to launch one in a couple of years, so we'll look forward to working with the Weather Service, learning how to use that data. Next slide, please. So just again, our recent progress. So we are knocking out the reviews that we have to do. And I'll just say recently, as it lists here, L3Harris, the people that made the imager last time are making the imager again for us. BAE has won the last 3. They're British Aerospace, but they're also Ball, so they're the old Ball. And they got the sounder, the ACX and the OCX. Spacecraft is at Lockheed Martin, and we're imminently going to announce, I think, who won the Lightning Mapper. We have a big set of reviews coming up with the Congressional Baseline Report submitted, and the MDR in December 2024. As you know, Andy Lotto is leading our user engagement. Advocacy is critical. We all know these are going to be tight budget years, and to get through them with all these instruments, we need the Weather Service, we need your advocacy, and we need these, this communication and give and take. Those that want the GeoXO shirt like I'm wearing, you can go to Land's End and get a nice logoed shirt. Next slide, please. The last one. Our timeline. We are here, 2020 in FY 2024. We've got to get to 2032. Again, all of our things are on a contract, except for Lightning Mapper, but that's coming. That congressional baseline is critical to get through that. And if you see these little triangles in 2025, we have a whole slew of reviews that we have to get through. We appreciate your help, and we'll continue to lean on the Weather Service support that we've gotten to get through that. And I think that's it for me. Okay, well, again, just a summary. We got a 2032 deadline we've got to make for our congressionally mandated continuity, and we plan this mission to go out to the 2050s. So it's a big deal. We need your help, and thanks again for allowing us to talk to you, in these events. So with that, I'll end. Thank you.
Thanks, Andy. Does anybody have any questions for Andy?
I'll stay on if you think of them.
Okay, thanks. Going to go to Satya's presentation. Next, we have Satya Kalluri. Satya, correct me if I'm wrong, so you were basically almost like Andy's counterpart at LEO, and whereas Andy would be GeoXO.
Yeah. Good morning, everyone. I'm Satya Kalluri. I'm Andy's evil twin in LEO. So similar to what Andy did, I'll go through the LEO program. Next slide, please. So the Office of LEO was formed this year with appropriation starting last year. If you click the next slide, what you will see is the LEO program has 2 components: the current program of record, which is the Joint Polar Satellite System, or JPSS, And then the future mission that is a follow-on to JPSS, which is the NEON, which stands for the Near Earth Observation Network. So LEO is the office, JPSS is a program, and NEON is a program. And under NEON, we will have several low Earth orbit projects. Each one is a different mission. Next slide. One of the unique features that distinguishes LEO from GEO is, in addition to global coverage, we make measurements in every part of the electromagnetic spectrum, starting from radio occultation, radio waves, all the way to UV waves, near AR, and the short end of the electromagnetic spectrum. Some of these measurements, like scatterometers, altimeters, microwave-based measurements, can only be done in LEO as for now. The reason is quite simple. It's the physics. The signal that is being generated or emitted from the Earth passively in the microwave is quite small. So the lower you fly, the better signal you get. And also certain technologies like radars and lidars are active. So again, it is one of those driven physics and engineering. You need to fly close to the Earth to do active remote sensing. Anyway, the purpose of this is we cover the entire electromagnetic spectrum. Next slide. And within NESDIS, we have what is called as the NESDIS level requirements. These are the top level, high level requirements that cover ocean and atmosphere, as well as weather and cryosphere. These are the different product category bins, and the purpose of this slide is to show that the LEO observations satisfy or cover all the product categories within our NESDIS level requirements. Again, this shows scatterometers, altimeters, lidars, imagers, RO, and so on. Next slide. One of the important features of the LEO program is we have a healthy partnership. Most countries, when they launch a LEO satellite, the data is collected over US as well. In addition to that, the LEO data drives the global models. So we have long established, well-established partnerships with trusted partners such as EUMETSAT in Europe, JAXA in Japan, ISRO, KNA, Canadian Space Agency, and most importantly, within the US, NASA and DoD as well. So partnerships is a very important contributor to LEO observations. In fact, more than 70% of the LEO data in terms of volume that we ingest into NOAA comes from partner missions. Next slide. So this is the current and future program of record. What you see at the bottom, post satellites. NOAA 15, 18, 19, these are legacy post satellites. They were launched a long time ago, even before 2000. And these satellites still continue to provide valuable data. And if you look at a NWP contributor, these three satellites are still an important contributor. And we tried to sunset these things a couple of years back, and then we got a lot of pushback from the global NWP community recommending that we continue to operate them because these fly and still provide the data that feeds global NWP. If you look at these legacy post satellites, as well as the current JPSS satellites, as well as our partner missions from EUMETSAT and others, we right now get global observations better than every 4 hours, right? So once these legacy post satellites go away, then the global refresh rate will drop down to 8 hours or so. So on the top is the future. I'll talk about the Quicksilver mission and NEON. Next slide. So if you look at JPSS, if you can click on that animation, that is the current program of record. And what we have now is 3 satellites, SNPP, NOAA 20 and 21. NOAA 21 is the primary spacecraft, NOAA 20 is the secondary spacecraft, and SNPP is the tertiary. The designation means that the primary satellite will get all the care and feed from the operators. The tertiary one is the least taken care of. The requirement is to have 2 satellites at any given time because of the criticality of the observations. So primary and secondary satellites very nicely back up, and having 3 satellites in the same orbit for redundancy. Next slide. Next slide. Here is the complement. We have a microwave sounder, ATMS. Chris is the IR sounder. VIRS is a multi-purpose imager. ARMS is the ozone sensor, and Ceres is the Earth radiation budget sensor. So what this shows is that we do IR and microwave soundings, which are the bread and butter of NWP. VIRS is a multi-purpose. It's not just a cloud imager. It does many other things like ocean color, aerosols, fires, floods, vegetation health, sea surface temperature, sea ice concentration, and so on. Next slide. So here is what I was talking about. If you look at on the right, this is from the Global Modeling and Assimilation Office, NASA model. Even though NOAA 2021 SNPP are still on the same orbit, separated by about quarter orbit, these are the 3 topmost contributor to NWP. And below that, after the METOPSy IR sounder, look at NOAA 50, right? That is the second most in terms of the cluster of measurement. Contributor, again, this is an old satellite. And then, of course, we have the AMSUs, like I was talking about, METOP-B on EUMETSAT and NOAA 19, 18. They still contribute, right? So the combined contribution of the posed satellites is humongous. On the left, you see a Hurricane Beryl, pretty picture. This is the VIRS image in the background. In addition to feeding NWP, the microwave sounders also make very good imagery products. You can see the delineation of the hurricane eyewall, which the hurricane forecasters love. Next slide, here is an animation capturing the El Nino through the second half of last year, 2023. You can see the Pacific boiling. Again, this shows the power of LEO observations globally. Next slide. Just like the GHOST satellites, if you click on these things, they should animate. The GEO satellites provide, very short turnaround refresh rate to create imagery. Over the lower 48, the polar satellites provide, very good coverage. Every 15 minutes over the poles, and if you combine multiple satellites, you still get almost 15-20 minutes coverage here. So what you're seeing on the left and on the right is the water vapor imagery. These are the same bands that we have on ABI. This is CRIS bands overlaid over the VIRS imagery. Next slide. Next slide. So yeah, the purpose of this is to show how you can animate. What happens if you lose a LEO observation? So this was a study that ECMWF conducted about a decade ago. Hurricane Sandy's landfall prediction was very well characterized, and ECMWF got a lot of credits for their highly accurate forecast of the hurricane landfall location, time, and intensity, especially that left hook there. So they did a data denial experiment. What you're seeing on the black is all the data from LEO satellites in the model. As you can see, the forecast and the prediction were dead on. And then in a following experiment, they withheld the LEO observations, and you can see the hurricane ends up somewhere in Vermont, which is hundreds of miles away. So this shows why we need LEO satellites to drive global models. And the impact of losing LEO can be catastrophic. Next slide. So we recently did some other analysis on hurricane intensity and forecast. This is for Hurricane Dorian and Lorenzo. So if you look at the experiment, the one in FP 360 is the observation with all the observations. Conventional is only blue. So if you withhold the LEO observations, again, you see a very big difference in how far the hurricane makes a landfall. And we progressively added microwave, we added infrared, we added radio occultation. The more we add, the better it gets, and that is very evident in these graphics here. Next slide. A recent study by ECMWF showed that the value of adding more and more microwave soundings to NWP has not saturated, and they have not seen any saturation yet. So they added 1 satellite, 3 satellites, 5 satellites, and 7 satellites. And as you can see, the benefits of adding more and more microwave soundings continue to increase. And what you're seeing on the left is, as I said, you have SNPP and METOP AB as the early morning and mid-afternoon. The legacy post satellites conveniently fill in the gaps. If you look at the WMO WIGOS 2040 vision, they recommend a 3-orbit backbone that provides refresh and coverage better than every 6 hours. So that is what we are trying to achieve. Next slide. So one of the early emissions that we have is what is called as a quick sounder. We wanted to look at what is called as the new space. New space includes a lot of commercial practices. We have a ATMS engineering demo unit that was built about 15 years back. So this is a prototype working unit. We asked the vendor Northrop to refurbish it. So this is like a repaired car. It's still functional. And then we gave it to a private company called SWERI, Southwest Research Institute. So this is one of those things where we want to examine commercial practices. For example, if we have a sensor, can we give it to a company and say, go put it on a spacecraft, you launch it, and you do commercial ground and antennas and give us the data, right? So we are interested more in the sensor and the data than all the other in-between stuff, right? So we gave a refurbished ATMS to SWERI. In 2026, the plan is to launch it on a commercial launch vehicle, just like we do. The data will be collected using commercial antennas, and they'll give it to us in a cloud, and we'll give it to the other service and everybody else. At the same time, we are looking at the future. The very first sensor we are looking at is called a SIMBA. This is a follow-on to the current ATMS, like I mentioned in my previous slides. The microwave sensors continue to be the bread and butter, one of the most high impactful. And once the legacy post satellites go away, we need to have something to have a global refresh of 6 hours or better. So we are going through a phase A part of the mission right now. So then we will have a IR sounder followed by an imager and an ocean color sensor and the other critical measurements that JPSS does beyond JPSS timeframe. Next slide. So in summary, we have more than 40 years of data provided by LEO that continue to be impactful for the weather community, and they're also used for climate and reanalysis. While JPSS is still healthy for at least a decade or so, we have begun in earnest to formulate the future follow-on missions. Thank you.
Thanks, Satya. Any quick questions for Satya before we move along?
If I could ask one. Satya, can you hear me?
Yeah, I can hear you.
Okay, great. This is Joe Sikowitz from Ocean Prediction Center. I'm thrilled to see the presentation, and where we're going. I have a question though on LEO and the scope of LEO. Meaning, you mentioned partnerships, but is LEO and partnership funding on the NESDIS side, is that in other words, the partnerships are great, but the data is maybe free acquisition, but it comes at a cost. I know one of the intentions early on was for LEO to actually cover non-US missions. Does it, as far as our costs?
Yes, we do. For example, if you look at the METOP's current satellites right now, we have in-kind contributions. The AVHRR and AMSUS are our contribution, right? So they do cost money. If you look at the UMETSAT follow-on, METOP second generation or the EPS second generation, we do not provide the space assets, but we do spend a boatload of money every month in providing downlink at McMurdo. Without the station in McMurdo, the data latency would be significantly much higher. So we do spend money on it. And as far as microwave, AMSR-2 is the Japanese satellite on GCOM-W, and there will be a GOSAT GW with an AMSR-3. We again provide ground coverage and reception over continental US, including Alaska, to bring down the data at low latency. And in fact, NESDIS, Dr. Walls wrote a nice letter to the Japanese government urging them to continue, and they say that because of that letter, they're able to fly AMSR-3. WSFM is a SSMIS follow-on on DoD. We are bringing that data soon. It doesn't cost us anything, so the data is pretty free right now. So the short answer is sometimes it costs money, sometimes it doesn't cost money. If it costs money, it is pennies to the dollar compared to building, launching, operating the whole thing by ourselves.
I appreciate that, and it may not play well in Congress, but actually having that as a bullet with NEON and LEO, under LEO, NEON and APSS may not be a bad thing. We heavily rely on scatterometry and, from the METOPS. And anyways, I'm glad to hear your answer, and I really appreciate it.
Yeah, one of the things that we get a lot of support, if you want to call it, and encouragement every year where Congress says, go buy more data, right? So we recently issued a commercial RFP to see if anybody can sell us microwave sounding data, and we expect companies like tomorrow.io to sell us the data. We will evaluate working with the Weather Service to see if that data is any value. So I have a small project with Weather Service to prototype that with tropics data right now. Again, we have to be vocal and forceful to say that the commercial data is a complement and a supplement and is not a replacement for our backbone missions. Otherwise, we'll lose our shirt. Right? Not a day goes by without somebody telling me the government is pissing off money building this fancy sensors. We can sell you a dime a dozen small sets, quick sets, right? So that is something that I worry about a lot.
All right, thank you.
All right, next we have Jordan. Jordan, what?
Yeah. I'm going to stand up here.
It's up to you.
I'll just come up.
This can hear you from anywhere.
All right.
All right, folks, welcome to our workshop. I'm Jordan Girth with the National Weather Service Office of Observations. Really appreciate you being here. Me and my colleague Brian and Jim Yo are kind of your go-to people for GeoXO related matters. So if you're curious, please don't hesitate to reach out. You'll be hearing from Brian and Jim shortly. But I'm going to talk to you about the imager. I'm the user scientist for the imager. And you've already heard the basic information. Excuse me. Got to grab my water here. I always like to start these presentations with a recent satellite image that I think is kind of interesting. This one from the ABI over the Midwest last Sunday night, so about a week ago. It's a water vapor image, and what it shows is some convection that developed over the Chicago area and moved into southern lower Michigan, and you got a nice gravity waves. The convective complex became an obstruction in the flow. So there's a lot of great things that you can see in satellite imagery. I thought I would just highlight this one for today. But back to the task at hand, as Andy talked about, we're going from the GOES-R ABI, which had 16 spectral bands, to the GeoXO Imager, which has 18 spectral bands. And I'm going to talk a little bit about what's changing, what's not changing, what can't change anymore, and what could still change in these next couple slides. So what's not changing, there's not any loss of current spectral bands in the contract that's been awarded to build the imager to L3 Harris. I should also note that most of what I'm saying here is also applicable to the Himawari imager. We realize that part of our service area is over the Pacific, so the national centers, Alaskan Pacific regions use Himawari. There's a lot of similar capabilities. I'll try to highlight where there's not similarities. There's just a few different spectral bands that are different. There's no loss of current spectral bands, so we're not anticipating any loss of current RGBs. The certain IR bands will continue at 2 kilometer resolution. That's the preferred spatial resolution. And the overall scan rate is not going to be changing either. So we're not looking at a increase in how quickly the motors on the ABI are able to scan. But I'll talk about in a bit, there's opportunity to perhaps alter the scan strategy based on your input, which is one of the reasons that we're starting these conversations now. And as Andy mentioned, the position of the spacecraft is going to be the same. So the resulting parallax is going to be the same. So if you've gotten used to that, that's a good thing. If that's a problem, which we continue to hear from our field offices, that there's still some challenges with parallax related issues, that's going to continue to be an issue. With the higher spatial resolutions, of course, we're going to be able to see some extremes that are a little warmer or a little colder in the case of convective cloud tops. That might require some slight alterations, probably nothing major to things like the Dvorak technique, but just something to keep in mind. The overall parallax, though, will stay the same. So what is changing? We have 2 new spectral bands. There's a 0.91, which is a visible near infrared. That is really looking at the water vapor concentrations that are under 1 inch precipitable water. So that's looking at lower concentrations of water vapor in the atmosphere. And also, we generally believe that this 0.91 is only going to be useful over land. Because of the very dark background of water surfaces, the 0.91 is likely to have little or no use over ocean. We're still investigating that. But Japan has already decided, because they're largely surrounded by ocean, to not have the 0.91. Also, the green has been a good contender. So the Himawari 10 will retain its green, not have a 0.91. But both Himawari and the GXI R series will have the 5.15 micron band. And that is a new low-level water vapor band in the infrared, so of course available both day and night. It is a little closer to that 4 micron, 3.9 micron cutoff, so there's a possibility that we'll see a little bit of solar impact as the sun rises and sets. But in general, I think there's a lot more potential, particularly in very moist environments for the 5.15. That was why we added that. We realized that we continued to call the 7.34 micron the low-level water vapor band, but most of you in the Weather Service offices know this, particularly if you're in the southern U.S. or you have tropical operations. The 7.35 was still really not seeing the boundary layer. It was seeing 600 millibars, and that wasn't low enough. So 5.15 is really for those tropical air masses for mid-latitude over the summer. Over the winter time, you will see the surface with the 5.15 micron. We're also going to have some improved spatial resolution. We're going to have some IR bands that are going to be going down to 1 kilometer, the IR window, and also a few of the water vapor bands. The 6.95 is going to be down to 1 kilometer for gravity waves. And the 5.15 is also going to be at 1 kilometer resolution, which we're adding. Andy also mentioned the 3.9 for fires is going to be down at 1 kilometer resolution as well. And the visible imagery is going to be down to 1/4 kilometer in the red, 1/2 kilometer in the blue. So we are seeing a fairly significant increase in the spatial resolution and therefore the data rate that comes down, even though we're going to be holding the temporal resolution constant. So what we can't change anymore is really that spec sheet that you see on the right. The instrument is largely going to be built for that order. And if we make changes, that comes at cost, so we probably won't be doing that. We had talked in earlier variants about low light imaging. We were really hoping to add that as a capability. We actually levied that as a requirement on the program. What we figured out was that there was some major challenges with low light imaging from a optics and physics point of view. From the geostationary orbit, unlike from the low Earth orbit, the sun is in view a lot more than it is in LEO orbit. So, and because of that, that introduces stray light. And when you're trying to see a very low light signal, that stray light is very, very harmful to that capability. So, we looked at all the times of the year that we could have low light imaging, which is essentially the times of the year and the hours of the day when the sun is completely blocked out from the spacecraft, and that just wasn't enough for the operational applications. And so we'll continue to investigate the capabilities of low light imaging from geostationary orbit. There may be some slight promises that we're seeing with the Tempo mission for air quality right now. But as an operational use case, we're probably not going to see significant low light imagery from GEO. Also, regretfully and with some contention, we don't have a green band again. We understand that, had we had a 19th band to add, that the green band would have been the additional band. We understand the importance of geocolor imagery, not only for operations, but just for great imagery to the public. Yes, we understand that there's some risk, but we also understand that the geocolor imagery that you're getting today that uses the veggie band is fairly good. And we're hoping that that's going to continue. Again, we're going to have the Himawari as a great training data set to make high quality imagery. And I'm guessing that most people will not notice it. But we do know it is a loss for people that are trying to have high precision imagery. What could change yet? So the scan rate, the capability of the imager to scan faster is set. However, unlike with the AVI, which the ground system dictated the scan strategy, we're hoping to have more avenues to improve that prior to 2032, prior to the launch of this particular spacecraft with this instrument. So we have an opportunity to look at how we do scanning. And that's not only the mesoscale sectors, but also the sizes of those sectors. And also considering possibly different strategies for east and west, or any of the above possible combinations of size, frequency, number of sectors. And we've talked a lot previously about 2.5-minute imagery. That was a mode that we were investigating implementing for the ABI. However, we realized that that would have come at too significant of a cost for us to implement. I would envision that that some variant of that will be back for GXI, and what it means to, again, to be a CONUS sector, we'll have to continue to revise that. But we obviously want to make sure that we're providing as much service equity as possible to Alaska. We realized that the GOZAR series really did not do a good job at making sure Alaska was provided the continuous capability that the rest of the lower 48, Puerto Rico, and Hawaii were afforded. Derived products, that's another one. And we know there's a lot of products that from the GOZAR series. They were set in 1999. There are things like K-index and total totals, which are a little bit dated, but that's why they are how they are. The derived stability indices were based on a memo from the Weather Service in 1999. So we're looking at products that are more modern. Of course, a lot of these things we're going to be able to do and can implement with ABI, but we want to do a better job for GXI. And so if you have any ideas on that in our discussion later, I'd be glad to hear from you. And then, last but not least, the blended or fused products with the other instruments. So we have an atmospheric composition imager, we have an ocean color imager, we're going to have a sounder, lightning mapper as we do now. How we blend those sources of imagery together I focus on really reducing clicks for forecasters to get the information they need. The sounder, the atmospheric composition instrument are going to be in a different location, so that's going to make it an additional challenge from an NWP perspective, from a cloud clearing perspective, but also from a forecaster use perspective, because the parallax is going to be a little different. However, we really want to look at how we can use data sets that we're getting together to give forecasters the best possible information. And so that will be a area of investigation that we undertake as part of our proving ground heading into the launch of this instrument. So that's a brief update on where we are with the GXI. If you have anybody else has quick questions now, I'm happy to take those. Otherwise, we can revisit your thoughts on the GXI during the question and answer session, open discussion session. And that's, again, the opportunity for you to really just sound off. It's not only just to ask questions, but if you're saying, hey, we gotta preserve the 1 minute imagery or whatever, we want to hear from you one way or the other about what you're thinking about this, because ultimately, we're representing our field interests.
Thanks, Jordan.
All right, thank you, Andy.
Lee, you want to read off a couple of the comments from this?
Sure. Scott Lindstrom earlier had mentioned that Himawari 10 launch date 2029 will also include a hyperspectral sounder, and that'll be available for use at WFO Guam and over much of the Pacific region. And a little bit later on, Reginald Reddy mentioned, until the Himawari, actually asked a question, until the Himawari 10 launch takes place, are there any key developments of note regarding the Himawari 9 satellite currently in operation?
No, I mean, Himawari 9 is just like our GOES 18 or GOES 19, if you will. We're expecting that the Himawari 9 mission will continue until the launch of Himawari 10, and we're not anticipating any major changes to schedule other than the regular housekeeping or maintenance for that satellite. So, good question. Always a good reminder for folks that may be listening from Pacific region, national centers that represent, that have service areas out there. There is a target area that is callable through international agreement. So, if you need more information on how to access that capability from Himawari 10, please let us know. It's something that I think we probably forget to stress. Japan is our partner in our mission. I personally consider Himori-10 goes east and west to be the full U.S. constellation, and we have agreements with Japan, and they're obviously using our vendors, so there's a lot of similarity and capability. So and we're working with in preparation for the GeoXO mission to perhaps even have a forecaster exchange with JMA, because their imager and sounder will be flying years before ours.
Thanks, Jordan.
Yep.
All right, thanks. I'm Jim Yo. I'm the user scientist, I guess, for the GeoXO hyperspectral sounder, the GXS. I'm not the only person who's involved in this by a long shot, and you can see my obligatory list of these slides stolen from here, but I won't go through too many details since time is limited. And my approach here is, it will be the 5 questions of journalism, or maybe not a who, but everything else. What it is, how we're going to use it, why we're going to use it, and how we'll exploit these data, and that'll come from the having a hyperspectral sounder in GEO. And what really gets me excited about this is just imagine, recalling the excitement we had with the ABI in the GOES-R series, where suddenly we had 60 times as much information from the imager, by virtue of having more spectral channels and faster temporal refresh, and as well as a greater horizontal resolution. Well, now we're going to do the same thing in the sounding realm. We're going to take the spectral resolution that we have from the, as we mentioned, from the hyperspectral sounders, the AIRS and CRIS heritage of our current polar series and DIASI, and we're going to do that same thing now in GEO. So we're going to be getting this refresh of really high density and highly accurate, high resolution sounding information. So we're going to be seeing parts of phenomena that we haven't been able to see, things we missed before on those polar passes. So obviously this is going to help us in the realm of numerical weather prediction, with the challenge of handling all that data. But I think also when we start talking about things, how we improve the real-time mesoscale analysis, we've got a whole new weapon in our arsenal. Okay, I'm not going to go in high detail through this. I've just talked about these changes that we'll have in spatial, temporal, and resolution, and spectral coverage and geographic coverage. We've mentioned a little bit also about having the ability to choose our scanning, and I think that's going to be a really important thing for us to sort out, is how we're going to choose between having full disk coverage with the sounder in order to support global and large region numerical prediction, the way we kind of do now, comparable to what we do with the LEO data, and when we want to have focused sounding information on phenomena of interest. But something I don't want to lose is that this all fits into something larger picture, the GEO ring of infrared sounding, where we will have, again, one from Japan, we'll have one from China, and one from Europe. So it's not just a matter of saying, well, we'll only have this high temporal refresh at over the central U.S. We're going to have essentially global coverage, at least in the regions that are well sampled from GEO. We'll have a challenge, of course, at the poles there. Okay. Applications are the types of phenomena we're looking at here. Just a whole lot of things. I'm always interested in winds and NWP, so that's a big deal, and the tropics here being emphasized, but not merely the tropics. Again, we should be able to see much better with our higher moisture information, the definition of things like dry lines, atmospheric rivers, looking at major storm systems, whether they're tropical cyclones. What's happening to me? I promise I had a very clean weekend. I should be able to speak. Tropical cyclones, regardless of which basin they're in, and also extratropical cyclones as well.
Jim, I think it's important to note on that slide, though, again, the geographic extent approximately of the imager, since we only will have the one.
That's true. But we will have again, the we'll have that fill in from our partners. And I would say make that point as about the partners too, is that of course we're not going to have our sounder until 2035, but the Europeans will have theirs sooner, and Japan, and it's really incumbent on us to learn how to use those data and how we want to use our sounder to provide the data that we need most and that we can use most effectively when we get the GXS up into orbit in the 2035 timeframe. Again, just a whole lot of things that we can have going on here with the sounder and a lot of applications. Yes, this will help us in terms of improved mesoscale analysis for a number of situations, both so-called, what I think of summer convective weather and also winter storms, word on forecast, because we'll have these updated soundings virtually constantly, or at least on a half-hourly basis if we're doing disk scanning. Fire weather, aviation forecast. Air quality, I think, is really going to be a huge factor for us with the sounder. I think in terms of having the ACX and the sounder on the same platform built by the same manufacturer. Now think of all you've got. The sounder is helping you identify trace species. So it's augmenting what you'll have going on with the atmospheric chemistry, but with the temperature and moisture information, now you've got information on reactions and depletions for chemical modeling, and with the dynamic information on transport. So you're really getting a full picture that I think will make our air quality mission much better handled than is currently possible. Challenges are just, I've alluded to before, is just the volume of data that we're going to be dealing with. I think that machine learning will be a big factor in helping us recognize patterns. It certainly will help us in terms of doing fast ready to transfer. And again, we have a decade to address that, but we really need to start now or we won't have all that time. There are science teams, that are being prioritized to work with, prioritizing what we can do with our available resources and to develop an integrated science activities plan. Really going through all these different things that we can do, the applications I mentioned before. So I'm going to let that be the end, and I'll say questions. I have one question, which is, I don't know who's going to be the user scientist after I retire, and Tim Schmidt is retiring at the same time. So that is a question mark. I have pushed hard on one person at EMC, and I think he's going to be stepping up, but I haven't seen it like in writing. All right, so I'll let you take your questions from the audience. And thanks for your attention.
Any questions online?
It wasn't that clear. We'll take questions later, certainly when we have the talking group.
All right. Thanks, Jim. Oh, let me give you
Hey, what does this button do?
No, not that one.
All right, thanks, Jim. Brian Gotzel here, Office of Observation. Good morning, good afternoon. I guess well, most of you good afternoon, I suppose. I'm here to talk to you a little more about LMX to add to the intro that Andy gave us earlier this morning. A little bit about the GeoXO LMX. Of course, we can't tell the LMX story without telling the GLM story, something you're all familiar with and most of you contributed to. I'll touch on MTG-LI, which is soon to become available, and some of the steps we're taking towards the integration of GeoXO into the Weather Service operations. So as most of you know, the LMX is another lightning mapper, will be another lightning mapper, single spectral channel, 777 neighborhood of that nanometers, like the GLM and the MTG-LI. For detecting the location and intensity of optical transients produced by lightning. Also detects other phenomena like sun glint and bolides and things, but lightning is the main motivator. There will be two of them hosted on East and West, like we have today. We can't say too much about it. As Andy mentioned, this is still in a sensitive acquisition stage. So the curtain's down, but we look forward to hearing an announcement. But the plan is for contract holds for up to 4 flight models. I think a prototype and then 4. So they would go on the wings just like we have today, not on the sounder in the center, but on the east and west satellites. And so there will be 4 of them if everything goes as planned, to east, to west in sequence. And the schedule is probably a little hard to read on the lower right side of the diagram, but this will give us lightning coverage from the geostationary orbit, east and west locations, starting in 2032 and extending way out into the late 2040s at least, maybe early 2050s. And of course, it provides continuity for the GLM, continuity and hopefully improvement. So as Andy mentioned, we're going to just speak to the requirements and the targets. The general philosophy, I'm not going to talk about all of these items on this slide, is that the LMX is targeted to be as good or better than the GLM. And some particular areas to mention, the program has encouraged innovation in this acquisition. So although the requirement is about 8 kilometers, or sometimes called the ground sampling distance, there could be potentially some improvements there. Detection efficiency, frame rates comparable, downlink is going to be higher, and that on the surface may seem like an incidental improvement, but that's critically important because it enables more of the spacecraft instrument data to be brought down in near real time, and it can therefore be further processed. And if there are artifacts or error corrections, there's a lot of that kind of thing that can be done. The coverage, we know that's been something that GLM is good, but we want to do better. I'm not actually sure about my 75% there. I've seen different numbers, but the LMX coverage is expected to be, the requirement is greater than or equal to 84%. And so we're looking forward for increased coverage. We know that Alaska was not covered, is not covered by the GLM, or not much of it anyway. And we hope to get more coverage there, as well as the Pacific region, as Jordan said. Service equity to the Oconus regions, as well as to the national centers that have responsibilities in those relatively outlying areas. Navigation and false alarm rate should be as good or better. Most of you are familiar with the GLM coverage. I think this is both of them, east and west, with the overlap, and there will be, expectation is there will be overlap with the LMX. We'll have to see how the solution pans out. That's important because there's going to be a couple of year time gap between the first GeoXO launch and the second one. And so while everyone won't be enjoying the LMX data right out of the gate, at least there should be pretty good coverage over the continental US, regardless of whether GeoXO I1 ends up in the east or west position. I think everyone in the room and on the call is familiar with what we use a GLM for. It crosses a broad swath of almost all of our mission areas, many forecast applications, a lot of synergy with other instrument data, and as well potential to improve weather forecasts as it is and will be assimilated into the models. The instrument's going to be as good or better. We learned a lot for GLM. A lot's been done since 2017 when the initial GLM product was rolled out. It was a bit of a thud, I think. Meaning no disrespect for those who worked on it. I think there was so much attention on the new ABI instrument, and it wasn't until we had a lot of eyes on GLM where it was clear a lot of work needed to be done. A lot of people in this room, and I'm sure some on the call, went through pretty heroic efforts to take that rough start and roll out the family of flash extent density grid products, the FED, the minimum flash area, the total optical energy, as well as the base 1 minute refresh, as well as time averages, 5 minutes, 30 minutes, and so on, as well as the the research and cooperative institute community integration of GLM into tools like MRMS and Prob-Sphere Lightning Cast have been really groundbreaking in terms of the ability to bring multi-sensor data, not just GLM, to the forecast for real problems, for solving real forecast problems. There's a link to the quick guide. I think all of you are familiar with the base family of products. And so we think these are working pretty well. We probably plan to continue those, but that's one of the things we need to think about between now and 2032. Is that the right set of products, and where do they fall short, and what might we add? Some of you, many of you, I think, are aware of the Satellite Book Club. I've got a lot of references to the book club in here. Eric Bruning and Joseph Patton's name come up a lot. They and others have done a lot of good talks at the book club and elsewhere. Work continues. There was a recent book club talk on the introduction of the data quality product, which relates to the detection efficiency. And there's not much of a caption here, but this is a goes east oriented picture from Eric and Joseph's July 11th, I think, book club talk. And it shows the decreasing detection efficiencies in the Northwest, farther, as you would expect, from the satellite subpoint that goes east, as another indicator for the forecaster when they're looking at a product. Where is it good? Where is it less good? As well, there's been work done on the background product for GLM that we, I think, are rolling out in some form and hope to be making it available. You can see some of the subarray artifacts, I think, in this one, the striping, but since it is a 777 nanometer single channel instrument, it's essentially giving us a near IR picture that updates frequently. So right now we're not sending that, at least I don't think we are, not operationally, thanks Lee for that confirmation, but we will be widening its distribution for evaluation and feedback. And furthermore, if there were an unfortunate event with the ABI, it could serve as a backup. Forecasters have seen it. It adds some value, not like the ABI, obviously, with the 8-kilometer resolution, but still would have some utility in the field if the unthinkable ever happened. And you're all familiar, I think, with the flash extent density, and forget what's in which quadrant. I think there might be an average flash area, which was later replaced with the minimum flash area, the total optical energy. And critically important in the upper left is the importance of using the GLM and the LMX data in conjunction with other observational data types, in this case, the terrestrial sensors, the Earth networks, which give the polarity of a lightning strike and fairly precise location of the strike on the surface of the Earth. So GLM, LMX, complementary with the terrestrial network, as well as with the other instruments on GeoXO and other satellite constellations. Thanks. I think this is another Joseph Patton loop presented to us at the book club. In fact, I think this whole slide is his, that the MFA, the minimum flash area, replaced the average flash area for reasons described there. So again, to the extent that these products are working, we're going to keep them, enhance them, and support them into the GeoXO era while adding additional ones. I don't say much in here about climatology, but suffice it to say that the GLM and the other geostationary lightning mappers are pillars of the establishment of a uniform way of measuring lightning across the hemisphere. So that's really new and exciting. As it says on the bottom there, lightning is the most prevalent natural hazard on Earth in terms of the frequency, millions of flashes per year. Don't want to leave out the NWP modeling community. Thanks to Jim Yo for providing an updated status on this. GLM data being assimilated into the prototype rapid refresh. And OAR, GSL, Global Systems Lab, continues developing GLM simulation for RF versions. It's not operational yet, but they will also be looking at MTG, LI, their lightning imager. And I don't think we have a precise schedule yet, but work is underway in that area with the expected improvements in especially short-term forecasting. A few words about MTG-LI. We're very excited that the Europeans have put their lightning mapper into space. There's two images here. The left is a loop, which I'm not going to do because I think you can see really what I'm including it here more for it's cool. So if you want to loop it, you can loop it. But what I really wanted to show is just the coverage. And the left and right are sort of the same thing, but on a different map projection. The Europeans, EUMETSAT, went with a different vendor and a different design. There are 4 identical telescopes, cameras, whose outline you can see on the right side there. And we're excited about this, first of all, an alternate option for lightning detection. And second of all, there's so much overlap, especially in the tropical oceans, for the Hurricane Center. Hopefully OPC and AWC can benefit as well as we learn how to use this instrument to fill in some gaps in the far-flung ocean regions to our east, as well as the overlap of the GOES East GLM and the MTG-LI. So the test data is available, sample data is available. The developers have started to take a look at it, and they're confident that we can do something with it pretty quickly. It's not flowing on a regular basis daily yet, but NESDIS is working on getting it ready on their cloud computer, their NCCF, NESDIS Common Cloud Framework, and Walter Wolf and his team tell us it's almost ready, and we'll be working on getting that to the centers for evaluation, and we want to hear your feedback on that. So we're pretty excited about MTG-LI. We consider it a stepping stone towards GeoXO, more experience with lightning imagers. This image just shows the side-by-side of GLM, not exactly maybe not so easy to tell, but you can get a sense of the overlap there from the Eastern Atlantic through the Azores, Canary Islands, all the way across just about to the Windward, I guess, including the Windward Islands, even into the Eastern Caribbean overlap with potential backup. Should there too the unthinkable ever happen, at least over that part of the world, high impact tropical weather and so on coming in that direction. So the road to GeoXO LMX, like Jordan and Jim, we are in lockstep and want to remain so with the GeoXO program to make sure that as NESDIS readies its constellation and its instruments and its ground systems, that the Weather Service is ready to put that data into our operations. As we'll talk about this afternoon, and most of you know, that's a bit of a slog, getting things into operation sometimes, and it can take a while. But we are committed, and we are holding our management feet to the fire, so they remain committed to keep these projects moving forward, whether it's the infrastructure upgrades, which we're starting to get some traction on, major Weather Service infrastructure upgrades, which we'll talk about this afternoon, and as well as critically the science, getting the best out of the instrument vendors, the laboratories, developers, prototyping efforts, as we do product development, so that we get to 32 ready to integrate LMX into operations as soon as that instrument turns on. Training to precede that, of course. Forecaster feedback for you forecasters on the phone. Your feedback has been pivotal in guiding the GLM evolution. Thank you for it, and thank you for your patience with our rough start with GLM, at least the Weather Service integration of it. And we commit to doing our very best to be ready for LMX ahead of 2032. And who's going to do that? Well, we're relying on many others, but there is a user team, just as Jordan and Jim are part of a user team for the imager and the sounder respectively. We have a lightning mapper team. Now, the LMX has been in an acquisition phase, so I don't know that we've even had a single meeting yet, but we're going to check it and check with everyone on this list and make sure they're aware they're on this list and still want to work with us, because we want to work with you and we want your feedback and we need your help. So this isn't, this is no one Weather Service office is going to do this. And GeoXO needs our help. They need Weather Service feedback because their development timelines take long too. So we hope to get these teams a little more energized in the upcoming months and reach out. You can help us you can yourself have a seat at the table and know that you have a rep at the table that we're listening to you and will do everything and anything we can at whatever stage we're at to make sure that your user needs, which are our guiding light and our prime motivation, are informing our decision making. A whole bunch of references here, and that's an incomplete list, but thanks all of the references there on whatever slide number this is. Just wanted to say thanks to them. And Flash Riprock, I didn't know this was still out there, but it is. If it's legal, it's on a NOAA website. It's about 5 years old for those who haven't seen it. But when the shocking truth strikes, it's too late. And so with NWS, LMX, we want to be ready ahead of time. So happy to take questions now or after lunch, whichever Andy team feel. And thanks for your time.
Thanks, Brian. We have one comment from Darren Fergursky that he said the MTG-LI would be interesting to take a look at. Yeah, well, I guess if anybody wants to have any questions now, I don't see any at the moment. So we'll have a lot more chance for open discussion here after the lunch break. Thank you. And for those on the line, we'll have we're having an external event tomorrow. The slides from that we're planning to post on the webpage later. So I'll share that webpage link to you all after about a week or so once they're available on the web. So some of these, it's the same information will be there. So we'll see you all at 1 o'clock. Thank you.
This conference will now be recorded.
Shall I begin? Yeah.
Sure.
Okay, Brian Gottel here, Office of Obs, back after lunch or your coffee break, depending upon where you are. This afternoon, this talk about the roadmap is much in part to update you on what the roadmap is, but also to help tee off the discussion, which Jordan will facilitate, and everyone's welcome to contribute to kind of a free-form discussion about where we go from here. So to start with the roadmap project, the roadmap is being done by a team in the Office of Observations. I'm joined by Jordan Girth and Fawaz here in the room, and we have other participants who I'll acknowledge as we go through the slides. We'll talk about what the roadmap is, why are we doing it, who we expect will be involved, what is the scope, and what are the expected outcomes, how we'll be communicating progress, how to stay in touch, and then we welcome any feedback that you might have. What is the roadmap? The roadmap is a plan for all the steps that the Weather Service needs to take to get from the current state we're at, the current constellations of satellites, as we move ahead towards GeoXO, NEON, New Space Weather, and many ancillary and partner missions. The roadmap itself will be typical of a plan in the sense that some project scope, the schedule of when activities will take place, and we'll be looking for any gaps in things that need to be done that are not yet planned for or funded, whether it's NESDIS or the Weather Service or one of our partners, and figure out who will do it and how much it will cost and when it needs to be done. So we'll have schedule, budget, risks, and all that stuff. It's important to realize that the roadmap is not, the roadmap team is not actually handling some of the big, heavy projects that need to be done between now and 2032 for GeoXO or the 2030s for Quick Sounder and NEON. But rather to make sure that those projects which are done are kind of mindful, cognizant of that the science, products, and infrastructure have to support that satellite data reaching the end users. So the impetus for the roadmap, we knew we kind of had to do some planning for these future missions anyway. We had to do it for GOES-R, we had to do it for JPSS. Once NES gets to the starting line with input from the Weather Service, as they are with GeoXO, and they're getting there with NEON, there needs to be that complementary commitment by the Weather Service to make sure that the Weather Service is making the investments, planning, and changes that need to be made on our side to make sure that that satellite data reaches users. And so on the surface, it might seem that, well, there's, the supercomputers will be upgraded, AWIPS is moving to the cloud, the networks are being upgraded, and therefore everything will be fine, right? We'll get to GeoXO and NEON, and these instruments will be turned on and they'll flow and everything will be good. But in fact, those projects could all succeed and we could still fail to leverage the full benefit of GeoXO and NEON, because in order for these missions to succeed, all of you who are familiar with the way data flows today, which is not the way it's going to flow tomorrow, it kind of meanders its way through numerous on-premises systems that are maintained and operated by different groups of people. And so quite often when a satellite forecaster finally gets to a product, it's been in the hands of several systems along the way. It's always been in the hands of several systems along the way, sometimes many systems along the way, many networks, application software managed by different people, developed, operated by different people. And so, yeah, we can have upgraded networks and we can have AWIPS in the cloud and we can have GeoXO and NEON launched, and we could still fail because in order for those missions to succeed, someone needs to be mindful and looking after the mission thread from the instrument, as Satya said, instrument all the way to the user. We don't necessarily care about what's going on in between, in the sense that's not what our mission necessarily is on the surface. But in order for that satellite data to get to the sharp edge of where the mission delivery occurs, which is the field offices, the WFOs, national centers, that the development, testing, implementation, testing needs to be done in such a way that the end-to-end, someone's looking after the end-to-end, satellite to user, so that if a forecaster clicks on, for example, a menu item or an NWP model cutoff occurs, that satellite data should be there by a certain time. And even if we're in the cloud, that solves some problems, but it's not going to solve all of our problems. And I don't think that NOAA, Weather Service specifically, and NOAA generally, should be too naive about the problems that the cloud is going to solve, nor should we underestimate the challenges that are going to require for us to get there. But thankfully, small steps are being taken already. So 18, 15, 16 months ago, Pam Sullivan came over and said, I'm doing GeoXO, I have a budget plan, I'm going to my requirements review. What Weather Service, what are you doing to start the preparation for GeoXO? And that was something of a, the wake-up call. We knew it was coming. And so that gave rise to a roadmap. And so AJ and Benji Spencer, before Benji retired, said, yes, we need a Weather Service roadmap towards GeoXO, towards NEON, these future satellite missions. So we didn't really have a team of people to do that. We said, yes, we could use a roadmap, but everyone's busy. So it's taken us a while to kind of get started, but Jordan, Awaz, and I, along with help of team members who you'll see here momentarily, are getting ready to start work on this in earnest. And so to borrow a slide from Andy Lotto, that is here, but I changed the words. Okay, so this is the Weather Service roadmap, which is similar to the GeoXO roadmap. Of course, it goes to GeoXO and NEON there at the end of the road. We're going towards the upper right. And we have some tasks to do. And this is just a high level outline. No need to read every word. The point is we're going to be doing things over the next few years to get us ready for GeoXO, NEON. And I don't want to omit space weather and all the important ancillary missions and international partner missions. This next slide has a lot of words on it. I'm not going to read them all, but I bolded some of the key points. Everyone knows NESDIS is going to be making available a lot of additional data to meet Weather Service and other requirements. The new instruments have new data formats, new capabilities that are not ingrained in our operations today. Just the volume of data alone, not to mention that it's different science data and it should be leveraged differently, but even the volume alone would stress our infrastructure today. And so these transitions to the clouds, both the NESDIS cloud and the Weather Service cloud transitions are critical, as are network upgrades that are planned. The Weather Service architecture is evolving. Some of the key points are listed there. Some of the key projects, networks in the cloud, networks and so on, move towards a consolidated NESDIS Weather Service joint data strategy. And so we want to ensure that these various quasi-independent projects taking place simultaneously across our enterprise are ready to kind of come together and will support the flow of satellite data and non-satellite data. And so many questions come to mind. How should we best exploit satellite data and observational data in 2030? Right? We can replicate what we've done today, and some of that's good and will be replicated, but there are also going to be new instruments and new ways of exploiting the data. And so the roadmap is going to ask these questions. What steps do we need to take this decade to get there? This is just a sampling of the upcoming satellite missions with the main backbone, if you will, NOAA missions circled. And this is mindful, or we should be mindful of the fact that there's GOES 19 is just launching, so we want to deal with that. That's got a new instrument for SWIPSI. The challenges this year that are in the early stages of our so-called roadmap, as well as the other missions that we've talked about this morning. Satya talked about NEON and Andy Heidinger about GeoXO. And so our task is pretty daunting. There are a lot of different proliferation of satellite data, more than ever before. And so it's as much a strenuous exercise of how to leverage these in operations, but also some hard decisions, right, about which products coming out of these various constellations might be good, but maybe they're not at the top level. They're going to have to be some tough choices because we can't accommodate all the data, and from a practical standpoint, we probably shouldn't accommodate all the data. We know that product overload on the menu can be a problem, and so it's not our goal here to roll out hundreds of new menu items to take level 2 products from all these constellations. So here are some of the folks that either signed up or have been signed up by their supervisors to work with us on this, and we appreciate their input. And there's a few TBDs in there, and their how and when we engage with the field is not so well defined yet. Gene Trescu and Becca Mazur happened to be on a call, so they signed up and we got their name, but we will be looking for input from others as we proceed further into this. And we always appreciate and acknowledge the contract support that joins us in OBS, and the longstanding commitment by the GOES GeoXO program. The TALRES team has done tremendous things working for both the program and the Weather Service. Lee Byron and Kashad are here in the room on the call, as Derek Van Pelt, P. Wegman, and others who work with us on these projects. Since we talked about GeoXO this morning, everyone's up to date on that. I'm going to skip these few slides here that you've all seen. The NEON slide you've also seen in Satya's brief. Pausing here on this one just for a minute. So GeoXO is going to be making data available to us in different ways. And so the NCCF, as the NESDIS folks know, and maybe some of the Weather Service folks know, that's the NESDIS Common Cloud Framework. And so NESDIS is moving gradually away from on-premises ground systems, except for maybe some of the key mission critical stuff they may keep, but a lot of the product processing, most of the product processing, and eventually I dare say all of the product processing will be in the cloud. NCCF is their cloud. And then, so that's going to be a big important data access method for us. Secondly, although GeoXO doesn't have a direct broadcast, so you will not have a satellite in your backyard pointed towards GeoXO. We're not exactly a GeoXO, but the GeoXO program is planning a commercial distribution of full resolution satellite data. And so we're going to have to see what the balance is as we get closer to 2032. Today we have 17 GRB antennas, and we're relying on somewhere between 4 and 10, depending upon how you count them, direct readout for the pole orbiting satellites. That's above and beyond NSDIS's antennas. Those are weather service antennas that are weather service or maintained by cooperative institutes. Antennas are a great way to bring in data directly, but they also pose some challenges. We're not so interested in being in the antenna business, but we are interested in bringing in very near real-time data. And so far, antennas have been a good way to do that, whether it's your SBN antenna or something else. So SBN is supposed to go away by the 2030s, satellite broadcast network be replaced by cloud delivery. GRB will fade away with the GOES-R series and be replaced by this commercial feed. And in our estimation, we will be less dependent upon satellite broadcast, which has a number of challenges. It's great for the low latency when it works, and GRB has served us very well. But the spectrum is getting more crowded, and the cost of maintaining antennas is non-trivial. But in order for us to make that cut, our networks have to be, weather service networks have to be stronger than they are today. There are still too many outages. Availability is not what it should be, especially in the distant regions, but not only the distant regions. And so I think there are those of us, and I'm one of them, who feel that's fine. We can cut the cord on some of these antennas, but you better get the networks to where they ought to be, because frankly, we still had some significant outages and key performance parameters this year, which left our forecasters without critical satellite imagery for hours. And they were, within the weather service sphere of responsibility. So we need to up our game in that regard. And as part of the roadmap work, we hope to work with the portfolios and the operations groups. So not only the Office of Dissemination, but NCO, and not only AWIPS programmatically, but also the technical people to see those mission threads all the way through, because we know high availability data, low latency, high availability is critical. That's our mantra. We should have it posted on our wall. Anyway, I've probably spoken too much about this, but things are changing on the NSDIS side. Things are changing on the weather service side. This is just a notional diagram, an option, but it does seem that coalescence, acceptance, and consensus is settling upon a concept. And this is very fluffy, cloudy, pie in the sky stuff, but it's important at this stage because conceptually, we need to agree on a concept, because in order for satellite to user to work, we, weather service and NSDIS, need to be in the same cloud. That was not the plan about a year ago. At least the fluffy, cloudy diagrams that some of us were seeing had a NSDIS cloud and a weather service cloud, and the concern was we were going to move all of our on-premises problems today into the cloud, into 2 clouds, maybe 3. One diagram had 3 clouds. It was going to be a NSDIS cloud. I wouldn't even go into it. There were too many clouds. This is important because there's now a team, a working group, where there's consensus forming that NSDIS and weather service are going to be operating, or at least sharing, a common repository for satellite observations. So that doesn't mean we're going to be in the NCCF, or for that matter, in the OSGI cloud. OSGI cloud being a development capability, NCCF being NSDIS operations, but NSDIS has concurred in principle, importantly, to write satellite observations, into a so-called data lake, consolidated repository. That's the same one that the Weather Service is using for the rest of our observational data that the Weather Service manages. Now that has significant ramifications for management and contracts, as NSDIS and the ground systems have a contractual arrangement with our cloud provider, or how to make sure the data is available at low latency. So details definitely to be worked out, but at least there's been some concurrence around the need for a common observational repository. And when I say observational, really beyond observational, because the Weather Service data lake, I believe the concept is that it's not just about observations, but also about the forecast products. The Weather Service ACIO, Chris Lauer and Becky Kunz are kind of conceptualizing about this. They've got a team. There's the OAPS in the Cloud team, and then there's this other team that is developing the NSDIS Weather Service Joint Data Strategy. So these are some of the principles that the team is kind of coalescing around and reaching consensus on. These are not decisions. It's just a strategy. This is the team that's working it. There have been several attempts to start this team earlier, but it seems to have started in earnest this summer. And we in the Office of Bob's, which includes Jordan, me, and Fawaz and others, are engaged in this working team. And here's some of the details about it. Not going to read all the words, but the important thing there is that this team is endeavoring to take on that end-to-end, that grand challenge of end-to-end, right? We're going to make sure that the satellite imagery that becomes available is all the way through to the systems that need it, whether it's AWIPS, the NWP models, or even the Research and Cooperative Institute and other communities. Ideally, we'll be working from common repositories that bring the scientists and the developers closer to the forecasts. And we've had some progress on that already with our TowerS team, giving cloud demonstrations of developmental products. Thankfully, since about COVID, gone are the days when we would have to send products all the way out to the field, and that was always a problem. Moving on, there are already in flight a number of development, prototyping, and pathfinding activities. I'm not going to read all these here. Some of them are kind of small, localized projects, but not only are they demonstrating the ability to deliver data through the cloud, but our developer team, our planners and our developers are becoming smarter about cloud technologies. And so, the organization is going through that growing pain of how to train the workforce. I mean, some of us will die away from attrition like me before this is all done, but the younger people are going to bring in new talent. And then there are people who here in the organization who are getting trained in these new technologies. And so these projects, even if some of them are rather small, we think they're very significant. And thanks to those who are working with them, who are enabling us to cut our teeth and learn what it's like to work in the cloud, because these pathfinders are really going to advise what our future architecture looks like and how it works. So along those lines, proving ground and training and products. So we talked a lot about infrastructure. The other dimension to this, of course, are how new ideas go from whether it's a need or a requirement, all the way at the top, all the way to the bottom, where it's a transition to operations, validation, to do what we deliver, do what we wanted it to do, and then importantly, what's coming out of operations that can inform research and development. And so that involves various steps, different products and capabilities and techniques require different levels of rigor depending upon how complicated they are, but some subset of these activities take place as we take the road from initial concept to development, proving ground and test beds. I think that's the OPG, a picture of Chad and Matt in the upper right, and the various test beds, and kind of capturing those products, whether it's a product or a technique or a tool, and figuring out should it be implemented on the weather service space? Because even though we're all in the cloud, right, there's different roles and responsibilities for what the weather service should be doing. Weather service management has been pretty clear. We don't want to do a whole lot of satellite data processing. It's fundamentally a satellite data processing problem. It should be an Estes' shop. If it's really post-processing for AWIPS, then it's the weather service. But we all know there's a major gray area between the two. There's some smiles in this room right now about that, because we're one NOAA, and it's not like you just cut the elephant in half. And so, but the point is that sometimes there's elements, pieces of a project that end up in both organizations so that they work together. But this road mapping team will be engaged in these steps. It doesn't mean we're going to be doing the research or the development, but we're going to be monitoring it and trying to help ensure that those promising projects are invested in and get the resources they need, to the extent that we have influence over that, to move them that much closer to operations. And we also have a lot of experience. Some of the team we have now has been working with JPSS, with GOZAR, in transitioning new products to operations. And so, or new capabilities to operations. And whether it's a product or a technique, implementing software, we have members of the team who've done both, and we expect to continue that. So I think that's the most of it. There's no particular ask today. You will be hearing from us. We thank you for listening, and we want you to know that our priority is making sure that these Weather Service attention remains on these new satellite missions, because there's work to be done. And I want to acknowledge Jordan, Fawaz, Lee, Derek, and V for their role in helping put this roadmap story together, even though we're just getting off the ground. And that's how you can stay in touch. And I'm losing my voice, so I'll leave it there. And thanks for your attention. Andy, did you want to do Q&A, or do you want to?
We have a question from Darren Figursky. Is it possible to get a copy of this presentation or share a link? Yeah, we can make something like that available.
Yeah, absolutely. Yeah.
Anybody else have questions for Brian?
Joe.
Right, you know where this is going. But you may. One is that there's a sample of products, and this goes back to international partnerships. There's no just consideration. There's no mention in there of any of the Sentinels. There's no mention in there of any SAR, RCM, radar sat. And I'm thinking of with colleagues here from the U.S. NIC, Ice Services Branch from Weather Service, and it's just. Yeah, I know it's on the periphery, but just consider that to be part of the mission.
Yes.
The other one is I'm surprised that NIMS is not being considered. You know, and maybe NESDIS and Weather Service is enough, but we're going to have an ocean color instrument.
Mm-hmm.
If all that works out, and that's the case. Plus, they're a user of SST data and a variety of different things.
Right.
You know, and I know that one's a hard one because they're really in a different world.
Yeah.
But they do use satellite data.
Yeah.
Yeah. Just a thought.
Yes, I thank you for that. First of all, from what I'm aware of, the GeoXO program has done some pretty aggressive outreach with fisheries. Is that fair to say? I have not been involved in that, but
We have actually our user scientist for the ocean color works for fisheries themselves.
Okay.
But we have been trying to engage with them quite a bit.
yeah,
No, it's good. It's good, but it's kind of a fresh start.
Yeah.
Because they've sort of been on their own.
right.
Just a thought.
Yeah, that's a great suggestion. Our direction was kind of Weather Service, and I don't know a lot about the fisheries mission, but at the very least, I certainly agree with you. We need to be mindful of it, and there could be interesting and new overlaps between exploitation of the ocean color, as you say, and potentially other instruments. So appreciate that suggestion. And with regard to the missions, if there were any missions, I should have mentioned in that slide that had a lot of missions. There were as many not on the slide as were on the slide.
Yeah.
And that scares us a little bit because, Joe, if it's any reassurance, Benji and AJ said, the ancillary missions are in the mix. We want to make sure that those are there for not only exploitation of the data for its own value, but also in as much as they contribute to either synergies with other missions or roadmaps towards our future mission. Because as most of you know, like scatterometers, Jordan's been a big proponent of the scatterometer, which we still don't have on NOAA satellite. We had quick scat 20 years ago, and then one that failed, I forget, around 10 years ago, and then SCATSat almost happened, and now we're on the ocean sat. And I know that's on Satya's radar with NEON. Because those ancillary missions are often the stepping stones that establish our ability to exploit the data and also facilitate it when we finally get an instrument on a backbone mission. So thanks for the feedback.
We have this discussion about GeoXO and this roadmap are major elements that are coincident. Because there's such a major IT shift needed to handle the data from GeoXO and the shifts that they're making to that mission. However, when it comes to the international missions, particularly the one that's imminent, which has been on SG, which is on Scatterometer, have new instruments, we're putting together a smaller roadmap or implementation plan for that. And we are looking at all of those missions, Sentinel, from ISRO, JMA, as part of future roadmap activity. So yeah, we didn't cover so much about what we were doing imminently particularly for MEDOP-SG and the other LEO missions, because those typically don't burden our IT infrastructure as much, but that doesn't mean that they're not important, and they're definitely things that we're watching. So yeah.
I appreciate that. And wisdom over decades, basically, you do see we fall into the same, it's easy to fall into the same habits that we've done in the past, even though, we're definitely going in a great direction. Thanks for that, Jordan and both Brian.
Yeah, and the other thing, I guess, to add to that is NESDIS is, as I think everyone here knows, is almost restructured to be the Office of Common Services, right? It used to be we're building a Go system, we're building a POSE system. There were separate physical systems and on-premises, and they are increasingly thinking multi-mission, multi-constellation. Even the name, Office of Common Services, the idea is, ground systems like PDA, I think was the first major attempt at that, where one system with distribution services met multiple constellations, and with NCCF, they're taking that to the next level. That said, I remain concerned at the number of constellations and instruments and products, and being realistic, there are going to be some hard decisions ahead. I'll just leave it at that. I think.
Yeah, if this was LEO user engagement, I think we'd have a lot to talk about in terms of data buys and how we're ready. And we understand some of your frustration that we've heard, from the field, that certain missions aren't getting to the field soon enough. They're up there for way too long before they're assimilated with potential centers. And our small sat capabilities and possibilities are only going to get larger. So yes, we are focused on the international missions, but we also understand that that landscape is changing. We're going to have to figure out how to be more aggressive to get types of observations that we need. I think a lot of that story is yet to be written about exactly how we go about that, because as of right now, we still have fairly formal government missions that we follow, and what we agree to and coordinate with through the WMO and the coordination group for meteorological satellites. But as you heard from Sacha, there's a lot, there's a lot out there that we can do and probably should do. We're hearing, for example, of commercial entities that are going to try to launch small sat scatterometers. How do we weave that into our plans, and how likely is it to be successful? How much can we hinge what we're doing based on the potential to have data buys? And there's no easy answers to that.
Got a question from Steve Goodman. What are your thoughts on accelerating R2O? It seems we do a good job prototyping, demonstrating, training, yet it takes, say, 5 years to get to ops, like central operations.
I am hopeful that cloud's not a panacea, but I will say a lot of our time and effort, as some of you know, has been spent to work around in various ways network bandwidth limitations in terms of moving data from point A to point B. That has been one of our Achilles heels over the years, and I think that is one thing, I think, that if this transition to the cloud is successful, as we all hope it is, that it will require less data moving around, and that has the potential to bring the investigators and the product developers and the forecasters who want to be like seeing new innovative products closer together. In some cases in the past, we literally could not send developmental data to forecasters because the SBN, for example, was too crowded. The terrestrial networks before the big upgrade in 2017, 2018 to the WFO, some of you know, were like, I don't know, 1, 2 to 3 megabits per second, and so you take one big satellite image and that's it for 5 minutes, and on those networks were really important stuff like watches and warnings and other things. So some of it's infrastructure. Some of it, I think we struggle a little bit with how we socialize developmental capabilities and first of all, develop them, verify them, but also how do we do trade studies to select the best of the candidates. I have found, and I'm interested in what others hear about this because many people in this room have done satellite development where we're spending a lot of time on our product only to find out it really probably didn't have the impact we thought it would have. Whether it was because of a deficiency in the product itself, or maybe the way it performed, or maybe it wasn't trained properly. The product was perfectly fine, but we didn't really get it fully into operations. So I realize my answer is a little bit nebulous, I guess, in terms of, if we do these 3 things, it's going to be really good. I wish I had that kind of answer, Steve, but I think there's a lot of challenges. Others?
Yeah, I've got quite a bit to say about this topic, but one thing that I noticed recently is that we have to get a very clear picture of what the field thinks an adequate product is for us to work on it. So there's been a couple flaws, one of which is these demonstrations because of our old processes. Our demonstrations would go on for way too long. We wouldn't try to formalize that. And so then it would get shut off and people are like, wait a second, we need this product. The other thing is, because our skills and the amount of data available to us is so broad right now, there's so many different sources, we have to really decide whether satellite is the best source of a product that we need to produce. And I think for ocean products like ocean surface wind products, that's still pretty direct. It's still pretty stovepipe. There's a lot of other products like total precipitable water that we really need to work toward more blended solutions that are integrating all of the data sources into one authoritative source. So if I can say one thing to the field is, if you have experimental things that have been going on for a year or more and it's not coming in through the main mechanisms that we have, make sure that you're recording that you have a need for that product, because right now as there always is, a shortage of money and backlog of products that Nessus needs to do. If your thing isn't in the queue, it's probably likely to disappear. The other thing is Nessus understands what the broader number of products that have to be transitioned are. They can set their budget lines a little bit better. Right now, or at least previously, they would fund a lot into R&D. Right, there's a lot of proving ground money. A lot of people were funded as liaisons. There was great work going on there, but an even amount of money wasn't stretched across the continuum. So when it came to the last mile of the transition operations, it was backing up. There's a backlog of products that needed to transition. So, every single thing that we transition has little issues that we try to work through, and I think we're learning through the process. We're trying to implement things like standard processes, standard data formats. But right now, the big issues that I've seen is just trying to understand is this a good fit for satellite products? If you need precipitation rate at a certain, accuracy, we have to really think about what instruments are going to be able to provide that, and if it's worth the time that we spend to develop it. Because I think, again, geostationary, we've got a lot of products out there right now. A lot of time went into developing those products. A lot of time went into transitioning them. And honestly, not all of them are being used. Some of them are used hardly at all. And it's like, if you look at the heritage, the millions of dollars that are put into that product, it's like, probably could have put that somewhere else. I could go on a lot longer about this, but it's a good question. I mean, I think the proving ground model has evolved. We're trying to learn best practices and try to implement those best practices. We're thankful for the field for continuing to work with us to do the best job on the transitions.
I'd like to add also thinking about this and listening to some of Jordan's ideas and thinking about what's transpired. I think another aspect to this that would be helpful is similar to the way there's that product prioritization team that some of you are working with Jordan on. I know Joe is and a few others, Jim. others are contributing to that, is we could use, I think, a team similar to what was I think it was called,
Satellite enhancement team.
yeah, the reps from each of the regions, because we're going to have a lot of decisions to make. And the science teams that we talked about this morning for GeoXO are good, but they're very much, this is the LMX team, that's the sounder team, and that's the API team. And that's important. Those teams have their work cut out for them. But someone needs to be looking across. And sometimes we find ourselves, Jim, Jordan, and I, making decisions, judgment calls based on what we think and what we hear. But there are many times, at least I know I'm faced with a decision where I really wish I could have a regional rep, a center rep, not but a group to look at these things and weigh in and say, this one more important than that one. Because I think that gets back to Steve's question about, it really is about priorities. There's a lot going on, and even in our own satellite world, there are some things going on that's like, why is that going on? There's a lot of people working on that thing over there. I'm not going to name projects right now, but sometimes they frankly are not at all aligned with what the management priorities are. And that's not to say that I agree with all the management priorities, but the fact is there are priorities and there are things going on. And I think that's some of what will help stimulate and invest in promising projects is having a clear sense of the priorities. And I think a team like the SET would go a long way to helping with that. Because we're going to have a lot of decisions to make with GeoXO, Neon, and the rest of them, we probably ought to think about standing up such a team. Jim, we'll leave that to you before you leave us.
This segues as well to another question for Rob Handel. He knows no rep from NCO or other national centers on the readiness team. Should they be added?
Yes, thank you. I think the NCO was still a TBD. We're going to start with Office of Dissemination, but we definitely want NCO involvement because they are so close to today's IT and having that. Some of the long-term strategic planning groups are a little, up in the clouds, and the people who have the fresh bruises and scars, who are working like complex IT issues day in and day out, they understand the challenges. And so we need that awareness of the gritty realities of what it's going to take to transition today's systems. And so, yes, Rob, we would like NCO involvement, and we'll be reaching out to someone at NCO for that, whether it's Ben, Becky, or Carissa. I don't know who the best starting point there is, but we will need their help.
He mentions there's two sides, IT and SDM sides.
That
was
right.
Two comments, and then we'll head over to the stakeholders session, or the breakout. The Sentinel constellation is a massive factor in their LEO readiness subplan. That was one. B. Wakeman.
Oh, V. Okay. Yep. Thanks, V.
And Dan Lindsay, one thing to keep in mind is that many products are not targeted towards weather service. There are other users, so that we don't necessarily expect weather service field to add a value or use for all those are products.
Yeah. Important point.
That's fine.
Discussion, more discussion?
All right, well,
Don't run away.
We're down to the discussion part. So, I guess we'll just open it up first to our guests here, not only here in the room, but also on the phone. If there was any, this is time for questions, but it's also time for reaction. If after seeing this, you have a certain opinion, you think, we're on the right track, you guys are really, hitting it out of the park, you're indifferent to it, you think we should make some changes to how we're approaching this. So it's all the above. So I'll just pause for a moment. You can put something in the chat. I think you can unmute to speak aloud if I'm not mistaken, or for those folks in the room, if you have specific things you want to add, things we didn't address, you can just raise them right now. Otherwise, I'll just maybe a question or two for you. We'll see what happens.
Anybody have a question? Sorry, the room one.
We'll simmer in the silence here for a little while and let people conjure up things before I
let things get people turned in a different way.
I guess one thing I'll say is that, those are, my God, we started so long ago, those are. And we're way into that period, but then again, that's sort of a natural, progression as we're going. I'm glad we're doing this. 8 years is scary me that it's that close, knowing I don't know how many years we started with those are, but it was like, early 2000s. I mean, it was a long time ago that we started talking about the next generation.
It's 1999.
It wasn't, okay, it was even before that. But I think the conversation here is really, really good. And it's exciting to see, where we're going, resolution wise, not latency, but actually, delivery, and we've seen what goes on, the evolution of imagery because of lack of latency and resolution. All of a sudden, it's a real tool for the gamut of what we do, as opposed to what it was before, as a confirmation of what had happened that you'd already seen in radar, for instance. Anyway, so I just want to say that to break the silence, basically, that I'm glad we're doing this, and I'm glad that we're going to continue doing this, to have discussion, and that way we're kind of aware of things. I learned more about NESDIS in this, kind of seen it, but it's never been really formalized to us, as to how their structure is changing, and it's way overdue. So yeah, I think this is a very good exchange.
Nothing online. Nothing online. You had that bulletin list. Maybe you want to bring that up on the agenda.
Yeah.
Topics. I could copy and paste that into the chat room. So it raises any eyebrows.
A couple things that we were, we have 4 or 5 different, I think more than that, but we have the data formats, coverage, tools and utilities, integration, the L2 and L3 products, and training as different things that we could potentially talk about here. One thing that I thought might be a good discussion, and I alluded to it in my presentation, was on the topic of coverage, and specifically coverage including the topic of scan strategies and what we currently have right now for a process for mesoscale sector selection. And I think this is an interesting topic, not only because we have an opportunity to change things for GXI, but we also have an image sounder that we have to essentially specify some type of scan strategy for in a way that makes sense. I think there's some folks online that have worked with the mesoscale mission manager and the MDS process. I know that through some of our road shows, we've gotten at least a little bit of feedback on that process, mainly for the for the OCONUS areas. But I just wanted to open up any opportunity for some opinions about whether that's really meeting the needs. And I feel like sometimes when we have these discussions, we always talk about everything from a very satellite specific perspective. And nobody wants to bring up some of the real reasons that mesoscale sectors aren't called, which is because I was too busy on the ship. I had other things to do. It was kind of interesting, but I wanted to eat my lunch. So what can we do? I mean, is the process as good as it can be? Should we make changes to that? Should we allow for larger mesoscale sectors? Should we have, maybe a sector that's halfway the size, a half CONUS sector that we, keep in one place and maybe move the other half of CONUS around? And if it's not moving around, then, then you have essentially 2.5 minutes. I don't know. So we have a blank canvas, so to speak, when it comes to scan strategies. And if you have ideas on that, we're very interested in how we can modernize that. We're not set to the shape of those squares. I mean, we can have diamonds, we can have, you know, if you want to spell out your name, no, I'm kidding. But there's a lot of different options instead of just having the size of the CONUS sector that we have now, the size of the mesoscale sector we have now. Any thoughts on that? Here online?
I'll see if anybody pops in. If not, I have an idea. Well, while we're waiting, you know, if from this is of course hurricane centric, if there was you always have to try to remember to do the mesoscale update, or otherwise you forget your storm goes off the screen or disappears entirely from AWIPS. And now that happened. You get really busy, and then like you look, you know, you see the loop, and all of a sudden it's gone. Like, right, I can get down there real quick and fix it. So if there is a way that from the hurricane center side, if there is a way to have somehow when they do like the initialization or something like that, that it knows to adjust it and refresh it for a few hours, that might be helpful. But I know things kind of change a lot, so it might be difficult for that. Or I don't know if it'd be something the SDM would have to do themselves then. So how do we worry about tasking them? Some sort of automation, I would think.
Right now, the center point does come through the SDM. I don't know if it has to. Like the way that JMA works their Himawari is they're constantly resetting the position. And, you know, I think we've explored what it would take to do that, but unfortunately, there's some limitations with the ABI. But for GXI, certainly, I think it is in our space of possibility to say, track this feature and let somebody else or some other program figure out exactly where the center of the storm is, so that you're constantly watching it instead of letting it run out of its fixed position and the storm moves on. And the storm is still on.
Did Mesos follow the eclipse? The ABI Mesos, did they follow the eclipse?
They did, but they were manually moved. It was like pre-scheduled to do that. That's a little different. Like if you brought up what they call a target area from JMA, like sometimes that thing is just shifting just a pixel, and it can almost get a little annoying because
right. That's the other side of it.
Yeah, it's hardly moving, but they're constantly keeping the storm in the center of the sector.
Right. And is that what the users want? Because the movement might be distracting. I don't know. Any thoughts on that from folks on the call?
Yeah, that would be really neat if we could maybe have like a start point and an end point and just linearly kind of move it through space to get to that point. Because then you could track synoptic systems, you could track tropical cyclones, you could track another eclipse.
Yeah, I feel like, you know, I know the TowerS team has worked on this a little bit already to see what can be done, but I feel like that's probably among the lowest hanging fruit for GXI is just that general ability to have a start and finish point, and maybe a speed and bearing or some way to figure out how it gets from here to here. That maybe it's linear, maybe it's not. But I feel like that would make us more consistent with what JMA's capabilities are today, which seems to work well for them. You know, we've also talked about a rapid, like an automatic rapid shift. And this came from the volcanic ash and the tsunami folks. They wanted some override in the system that essentially, without manual intervention, if a major cloud just formed, you know, several sigma off of what a normal cloud grows, then all of a sudden the mesoscale sector just moves there, right, without needing somebody to intervene because it's most likely a volcanic eruption or something else happened that was not meteorological and, not consistent with normal meteorology, I should say, climatological meteorology. So, you know, that idea has also been thrown out. It doesn't seem like it would have mattered a whole lot in the GOES-R series, with the exception of Hungatonga, which we missed. JMA also missed it because we didn't really have a capability to move quickly. And eventually, I think the Storm Prediction Center was like, we should really look at that down there. That's kind of interesting to have one minute imagery of. But yeah, we've taken quiet seismicity over the Western U.S. for granted for many, many years now. We don't know if that's actually going to continue. Alaska's also been relatively quiet, though they have a few that are stuck.
Jordan, I might just say that's a really great idea. And I think that's probably one of the top priority things to do, because of volcanoes, these things that happen so quickly, you just can't react to them fast enough to get useful data. As long as you can avoid a bunch of false alarms where it's just bouncing all over the place. So really, I think that it can't be overstated how important that one is.
Something from Bryce Tyner. Has there been some discussion on eliminating the rigidity of the sector priorities? Where it can be, where it's going to be centered. He knows at the WFO operational level, they have a few instances where they've been denied requests due to what seemed like an automated determination of a higher priority item elsewhere. However, in the terms of usefulness of the sector, you'd argue the rigidity of the prioritization should have some leeway on certain day-to-day applications. So perhaps, I think a justification statement requirement when submitting a request.
I mean, I'll react to that. There might be others that want to react to that. The priority list has pros and cons. It takes a lot of decision making out of the process, so you know exactly what's going to happen. It takes a lot of decision making out of the process. I know that I think that generally people agree about the items that are on the top of the list. Those are at the bottom. However, we've heard some cases where maybe some more thought is needed. The case that we heard from the Hurricane Center was we have a developing tropical system in the morning, first visible light. It'd be really nice to get the mesoscale sector on that system, even though it's not a high intensity system. It may be not particularly threatening at that point, but it helps the value of that mesoscale sector to the forecast operation may be higher than for a higher priority item. And I know this can get kind of tricky because sometimes that's an eyes holder, but I have heard those cases made. I don't, like anything, there's not an easy solution that I'm going to be able to come up with today. We're, of course, interested in people's opinions on it. I still am of the opinion that trying to increase the frequency of the CONUS scans and leave the mesoscales for more OCONUS type applications may be a better operating procedure to reduce the amount of kind of prioritization conflicts. But it doesn't come without challenges. I think that what we would have to do is have, as I mentioned, kind of a half CONUS sector that, East was just doing East, West was just doing West, and there would just be a little bit of overlap. Right now, West does most of CONUS, East does all of CONUS, and so CONUS is actually getting scanned quite a bit. It just depends on your parallax preference. But if we cut down that CONUS sector size, then we would be able to scan that portion of the CONUS more frequently, right? So if we cut the CONUS sector in half, right there we'd be able to do 2.5 minutes. If we cut it in half and remove the mesoscale sector, maybe we'd be down sub 2 minutes. Is that worth it? Some people might say yes, some people might say no. But it's something that's there.
Yeah, and it would be valuable if it could be sort of done or undone when needed, right? When I say that, like say we have an incident with one satellite, and so with GXI, you said earlier, Jordan, that there's going to be more flexibility in the scanning. Hopefully that it can be programmed to say that, maybe we'll have the full CONUS done, scanned regularly. But when we have 2 GeoXO up there and have the option to quickly change the CONUS sector dimensions, then at that point, revert to an option where we're just scanning half the CONUS and elsewhere other times.
The other thing that we've heard of, and this is weather service only, so we're not going to hear a lot of advocacy for Southern Hemisphere. And if folks from American Samoa are online, I'm not quite talking about you, even though I understand you in the Southern Hemisphere, is that if we scan the Southern Hemisphere less, we can scan U.S. interests more. And that's also a capability we don't have. We don't have the ability to do just a northern heavy scan today. We have to scan all or nothing. Although somebody did say that if you continue to just request mode 5 mode 4 every 2.5 minutes, that technically it's possible that you could do like a 2.5 minute northern heavy, but that has its own flaw that we got to commit to from this, because we just don't have that built in. We also don't have the ability to do just very unique science things during the normal operations. Like this instrument and the GXI are capable of steering in a very quick interval if we really wanted it to. I don't know why that would be necessary. However, with an additional increase in spatial resolution, we might be able to improve our vector approaches by having the delta spatial resolution even better than it is now. So you're tracking a little cloud and it's moving through a 250 meter grid instead of a 500 meter grid. Well, now you're getting closer to resolving that individual feature and being able to track its speed better. So there's some possibilities that may be beneficial. What we haven't heard though is the operational case for that. Nobody's saying give us 10-second imagery, 5-second imagery. We rarely see even uses of 30-second imagery. So if that's something that you think you want out of this instrument, speak up, because we're not going in that direction right now. We're focusing on the resolution improvements and trying to optimize the scan, not necessarily the scan.
Mindful that the request to scan quicker will come at the expense of something else.
It always comes, it's always a trade. As I said, the scan motors GXI do not, they're not any better than what we have currently, right? So in a perfect world, we'd be able to do whatever we want to do with GXI now from a scan strategy perspective of the ground system. All right, any last questions on comments on that?
I don't think it's directly based on, well,
if it's a comment, let's hear it.
Well, there's 2 questions. One's not directly related to that, but the next one is. Maybe I'll ask the second one first. If there's a Joseph Fiore, is there a half CONUS sector or something similar? If there is, then you may be able to have multiple types of events, hurricane, fire, weather, or other high priority events covered in the same sector. Often now they can compete for priority.
Yeah, I mean, that's kind of the goal of having a CONUS related sector, is that most hazards would be covered similarly. If we had a 1.5 minute sector, for example, overall of CONUS, then you wouldn't really have to move anything. So the question is, can we get it good enough or close enough to 1 minute that we're reducing the amount of requests coming in from CONUS and then just leaving a sector for the whole CONUS, let OPC and NHC, CPHC for the West, coordinate on the use, a much smaller subgroup, because the forecast offices that essentially be taken care of through a consistent sector over CONUS.
And Jack Settlemeyer, does the prop severe algorithm make use of the mesoscale temporal detail? Like, could it go perhaps reveal more storm detail, aka some of the plots Tom H had produced? Just thinking out loud as you see some of the AI-based post-processing offs does on its output.
I guess I don't know the answer to the specific question about prop severe and the mesoscale sector. I don't think that those 2 things are correlated, although I'm not 100% sure, so if somebody knows definitively, please interject. But I think that the Prob Severe is based off the general scan strategy, not the mesoscale. But to the larger point about AI-related tools, I think that that is the kind of L2, L3 product that we want in the GXI era. And we understand that there's a high value of that product to the field. And that because it combines multiple data sources and is displayed in a way that is not necessarily onerous, right? You don't need to click separately, load it separately. It doesn't cover the radar imagery up. Yes, we know you need radar for severe weather. I get it, but those are the kinds of products I think we're seeing a similar, I mean, the volcanic ash product, and there's a fire system that's being developed right now that's similar. I think those are probably more of the products of the future, if you will, than what we have currently as a bunch of kind of monolithic single satellite-based products.
All right. That's all I have in the chat right now.
Okay. Doing a lot of talking. We need to hear more from our stakeholders.
Here we go. We got one. Could we add a scanning strategy new mode and let ops vote by how much they would use the full CONUS or half CONUS imagery?
Yeah, I mean, I think there's a good ideas for how we figure out. There's a whole career path and new product development. And sometimes I don't think we exercise the best practices for new product development and know enough. I think sometimes we rely on subject matter experts or people's opinions. But I think we have a really good opportunity to try to we can simulate the different scan modes and actually put them in front of forecasters and have a pretty wide voting survey approach to figuring out what the best ultimate is. The pros and cons and concerns and benefits of each single strategy. So I know we've done a little bit about that previously. I think, Andy, that's something that in future engagements we probably should put more time and effort into coming up with ideas and putting them forth to this group and to our user teams, and continuing to come up with the best approach. We certainly have the time to do it, so we should put our time to good use.
And Jordan, just following up on that, what I'm essentially getting at there is that if it's possible to have an additional mode option in there, that if we're not limited by the number we have currently in the different scanning approaches, could we just add that one as an option, sort of like for those days like that one forecaster was mentioning where you can't accommodate all the requests and you want to accommodate all of them. So, you could go for that. It actually is more like the old RSO at that point, than the mesosector. And there's a lot of instances, even in the eclipse, the mesosectors covered a fairly small area. They didn't cover the entire eclipse. So there might be a lot of instances that it's better to have a wider view.
As far as I know, we have an option to add. We can add many more modes than just 6. And I don't even know what happened to modes 1 and 2. Nobody even talks about that anymore. I haven't had this conversation specifically with GXI, but given the AVI heritage, we can load what they call different time charts onto the satellite. So what we have to convey to NESDIS is they need to be able to handle different, have more agility in the types of time charts that we can upload. So yeah, we can do it. I think we have to obey by certain constraints, like the images. We have to, once we get started on something, we need to have what's called line adjacency oftentimes. So if we scan something like the northern part of CONUS, we can't go scan the tropics and then come back like 2 minutes later and scan the next line, because then there's going to be a gap in the image where, as you mentioned, the clouds move, and so we don't want that artifact in the image. So we have to obey by those constraints. But Other than that, everything on the ABI right now is limited by the ground system. It's not limited by the instrument. The vendor is fully capable of putting in very unique time charts. You know, as I said, you can pretty much draw letters on the full disk if that's really what you want to do. It's that capable. You can come up, down, sideways, and do it in very, very rapid, like a few seconds. It can slew across the earth. So, you know, whatever you want to do with that, I think, you know, we'll have plenty of options. I don't think we're going to, you know, have it open to the field to draw things in their AWIPs instead of directly to the spacecraft, but, you know, close.
Did it come up in the discussions about whether these different scan modes would affect the instrument lifetime at all, or it's required to live X years, you know, in operations? And so is it the assumption that pretty much regardless of what we choose to do, where we put these sectors, how long we dwell there, how long we move, that it has no appreciable impact on the lifetime of the instrument?
That's what and again, some of these discussions I've had for ABI, not so much for GXI, so I'm just assuming the answer holds. But yeah, we've generally been told that it's very difficult to over-exercise ABI. You know, like really the hardest workout the ABI would get is in mode 4 because it's constantly going back and forth. So pretty much anything is better than that. You know, they talked about maybe you don't want to keep slewing, you know, across the whole disk from the furthest extremities, but doesn't seem like something we would really do anyway.
So I take it happens occasionally today if we have a CONUS, or we've got two mesos that are.
And a star look that we don't see that on the imagery side, but absolutely. I mean, sometimes that thing is going, it's in, you know, South America, it's grabbing a hurricane in the Atlantic, then it's looking at a star, and then it's back in South America. So and it does that, you know, all within 5 minutes. I mean, sometimes within a minute, it does 30 seconds, it does all that. So it's already, I mean, the instrument is highly capable of slewing around wherever you want to look at. And it's hard to envision. I mean, there might be some engineering limitation that I'm not thinking of right now, but I think generally that's not a major concern.
Good.
You want to switch topics?
Yeah, I'll throw another topic out there. Training. What do you think about training? Yeah, how's the current training? People need more training. You know, we've heard this, so the current training is 8 years old. I don't know if any of you work or any of you are new hires to the agency. If you like the training, you hate the training. We want to make the training better. We want to make it more relevant. If you have any ideas for now or well down the line of what you think about the training, how much time we should spend training, maybe for the, I'm saying this, by the way, I know we've talked a lot about the imager and the scan strategies, but we have an imager, sounder, and the lightning mapper. Big training gap we're anticipating is actually not going to be with the imager, which we assume most people are probably going to know, because the bands are largely all the same. But the sounder presents a new data set that, you know, we've had some folks using UCAPs from Leo, but it's really pretty different. So, you know, again, now's your time to say anything about training. You can talk about the format. If you want it to be more experiential, if you want to go to Japan, I would want to go to Europe. We're not going to guarantee that that's going to happen to everybody, but we want to give, probably won't. But we want to give everybody, yeah, these are expensive. When you look at one thing maybe we should say when we start this, just to finish the discussion. If you look at if you combine the GeoXO annual budget with the Weather Service annual budget, the GeoXO budget would be half of the Weather Service budget. And the weather service budget equals the GeoXO budget, essentially. There's a little bit of deviation because GeoXO has a ramp, but if you have flattened it out, that's approximately what it is. So given the amount of money we're spending on this satellite series, we don't want to say, like, well, we don't really have enough money for training. You know, here, take this boring, is that TLC teletraining, right? We want to make it engaging. So for GOZAR, we actually have brought in the science operations officers. We did in-person training. But we're open to your ideas. You know, what do folks think is the best approach to bringing people up to speed, particularly on the sounder capability, so that when we do have that capability, that people are ready to use it.
And at what point in time would you like to see that training take place? We know people have opinions about that.
So that's right. Yeah, it's another interesting issue.
Anybody will chime in regarding that?
I will say that goes hand in hand with the scan strategies that are decided upon, right? So you want to have those settled and then you train on them. Sometimes today still, when we're looking at AWEB's day-to-day, we see the way the mesosectors are called sometimes doesn't really suggest that, you know, there's really sometimes a lot of education on what's provided when they're overlapped almost exactly, and you're not getting anything really added because of that. Or a 30-second meso is a single meso.
Yeah.
Sometimes that's, you know, stuff like that is still being learned. It's still pretty new, it seems.
And keep in mind that if there is overlap within AWIPS, there is that 30-second stagger, so it becomes 30-second imagery. So we've actually kind of backed off the sort of concern about making sure there was never overlap, because that allows in some of those areas where there's actually more of the active weather that you get a part of that scan is and by default 30-second if it's overlapped.
Thanks, Rob.
And coming in on training?
No.
No. No more training?
They're like, no.
All right, well, everybody's getting 20 hours of teletraining for the next generation. So you had your chance. I don't want to hear it. We're really going to try to do more than just teletraining. I know we still want to continue to work on new hire training, specifically for satellites, try to figure that out, try to build it more into the specific missions of the whoever that forecaster worker works for. We want that to be more relevant instead of, you know, what we used to train. The easy way to train is to say, you have a satellite, we're going to train you on the satellite. On the flip side, you should really train you step on the mission, right? And the satellites are the tools. So then it's just going to be one of the tools. So, you know, that's the shift we're trying to make in training. It's not an easy shift to make, but we think that that's more valuable. If we talk about the mission service series of the cases, instead of just talking about satellites as one thing. And sometimes satellite's the only tool you have, and so that works out a little bit better. But if satellite's not the only tool you have to use it, or you have to use it, you know, model data, other sources of information, ship reports. We want to try to approach it from that lens instead of saying, here's training on just the satellite part.
And even sometimes worse than that or more narrow than that. Here's training on the GOZAR.
It just goes on.
Yeah, here's training on JPSS. And so to our NWS friends on the call, is there, since there's more effort on enterprise, we heard from Jordan about blended products, multi-mission products, and we may not be able to solve the train on everything. For NSDIS, we can't expect NSDIS to solve that problem for us, but is NSDIS planning for training that is, you know, multi-mission, multi-constellation? GeoXO has a training budget. LEO and NEON does or will have a training budget. And is there a training budget that is for these ancillary missions that aren't necessarily part of a big program?
I'm hoping somebody chime, I think Dan's been on the call, so maybe he'll chime in with an answer if he's got one. While we're waiting, since I put Dan on the spot, hopefully. I know from a weather forecast office perspective, some of the most useful training was when they threw you into the WES simulations. And they would have all the ingredients put together, or sometimes they'll remove one for you just to make it more fun. So I thought stuff like that was a good way to really learn how to interrogate, especially with what the data was available. But it'd be important if there's new products that try to purposely build new cases that have that information in it and kind of force the forecaster to use that information. And they'll remember that for the next time they come around. Think, okay, now I have this. I may want to add it to my AWIPS toolkits, and add to my list of weapons to use while you're in the hot seat.
It's tricky. I mean, I think that we generally do training in the Weather Service. Maybe things have changed, but we generally train kind of a lot, right? I mean, it's just a lot of kind of learning on the job. There's not a lot of the airplane model of, putting somebody solo in a situation and having to figure it out. It is, kind of repeat until you build a certain level of competency. I'm not sure which way is better or worse. I mean, there's pros and cons to both. Obviously, the reason they do that for airplanes is, you got to be able to fly the airplane, whereas you're not in such a dire situation. Surface spinning, but there are some pros and cons to that, because it is easier without becoming overly comfortable. You can fall into using the same data sets and not really, evolving skill sets. That's one of the challenges. Is if you things that you're not familiar with, you're less likely to use. It's just right. I mean, it's like all those buttons on your car. You probably know about 8% of them, but you'll probably use the other 20%. And there might be really cool things. So I think, with training, that's one thing we'd like to see more. Yeah.
One thought with going to the cloud, does that open up the opportunity for more of the interactive training that Andy was mentioning with the WES, and I think I heard the data lake, I think on one of your slides, Brian, it said it would be 12 months of data potentially in that data lake.
They are, yes, they're mindful of it. There's even debate to go about further than that, but
Sure.
Yeah.
But I think recent events would be good for training and being able to capture multiple events and look at the same product over time may be helpful.
Right, and also, Stephanie, I don't think I got into this, but so OSGI is the Office of Primary Responsibility to develop the data, right? For us, you heard that somewhere. So we're assuming that's true. So Ken Spiro and his group are going to do this daily, and but at some point it's going to be operations. You have to do operations, which means they got to give it to someone else. So we're not sure what that is yet. Probably dissemination, maybe central processing. But the reason I bring it up is because we hope there will continue to be a data lake that has the full, even better repository, right? The developmental products that are not yet ready in operations. And so that if it all pans out, then that data lake should provide the data sets needed to do the weather event simulations of case studies that really bring the forecaster into the heat of the challenging forecast problems while they're training. So I think there's some potential there.
Yeah, I think so, for sure. It's much easier to bring things together in real time, a little faster. That's one of the things that Kashad and Emily could bring back from their travels on the book club seminar series, not to talk for them, but is just so much overwhelming amount of information from different data sources and menu items. Is just, if there's some way to have that kind of training just in a quick little bite-sized pieces. And sometimes it doesn't have to be a whole full-blown WES simulation of the last 4 hours, but just for this next situation coming up, or what happened yesterday for 15 minutes? Are there some products that could have helped us that maybe we're not aware of? And maybe having access to them in the cloud from yesterday is easier than loading up the whole, a big, huge everything. Of course, I know I'm talking sort of myopically about satellite, but that's some of the feedback that they bring back that we're aware of. Kind of the quick, like you said, living in the live, doing things in the live.
Nothing in the chat.
Nothing's coming in. Necessarily know if I've got too much more. We could probably wrap it up then and have people keep in touch.
For anybody that's, we have a separate meeting with similar content tomorrow morning. And we also have a stakeholder session. This is for everybody that's non-weather service tomorrow. Anybody that's interested on the call or in this room, you're welcome to join tomorrow if you want to hear from some of those external folks.
This was so good that you want to do this again tomorrow. I will be impressed.
Well, especially the admin portion, where if you want to hear them, hear what they have to say, maybe it'd be interesting to have that cross interaction between weather service folks and external folks.
It is interesting. I mean, I think one thing that we want to hear from our users in the weather services, part of this is we communicate to our partners what role, if any, does satellite imagery products have. I mean, clearly we know the power of the hurricane imagery on the screen, really causing people to evacuate. They see it, they know it. It becomes real to them through the imagery. There might be more examples like that we need to uncover as we provide decision support services or post things online about how satellite data is helping us communicate our message to mariners, to the public, other specific use cases, fires, firefighters is another one. We're still trying to unpack those elements, and so we're looking forward to hearing from folks tomorrow. But if you hear things from your forecasters about, well, it'd be really great if it was part of a briefing package I put together. I always had this kind of image of this image of this storm. Those are the kinds of things that we're also thinking about. It's not, sometimes we think about products as this big science innovation thing that we put a lot of time into. But if it's really just something that goes into a briefing package that's like always there, like I always want this image with this color enhancement, because our partners can get at this, they can show it on the screen. It's really helpful and we explain what's going on. And maybe there's satellite data, overlay with the surface analysis or other forecast or added information. That's just as good information for us, because ultimately, whether this satellite data is serving the forecasters who are serving the public, or the satellite data is serving the public directly with the help of our forecast services, it's all the same for us to increase the value of the mission. So please continue to let us know that we don't have to think about products in this kind of traditional sense. Like, there's the drawing stability index or aerosol concentration. We can talk about it more in terms of what you need to show to the public. With that, wrap it up.
All right. Yeah. Thank you, everybody, for joining us.
Thank you. Thank you for your time.
If you want to spread the word, we have another one exactly like this on the 27th. In case people didn't make it, we have a virtual one on the 27th.
Or you can come back on the 27th too, but that one will not be in person.
Yes.
You don't get the benefit of face-to-face.
Yep, they missed out, unless they come downstairs tomorrow.
That's right. Yeah.
But thanks, everybody, for coming out, and y'all have a good rest of your afternoon.
Thanks for organizing it, Andy. We appreciate that.